Hello, everyone. My name is Nia, and welcome to today's webinar. We'd like to give everyone a minute to join and settle in. Please use the chat to let us know where you're tuning in from. And make sure, when you respond, make sure you put to everyone, because there may be someone in the webinar that's in the same location as you. And I do see a lot of people joining, so please make sure you're dropping your location in the chat. Make sure you're putting to everyone, because someone may be in the same location as you. From the Netherlands, Pakistan, California, Manchester. Oh, wow. So many people all over globally. I love that. And thank you for everyone who's it's later in your time zone that's joining. We greatly appreciate that. We have a lot of people from India, someone from Nigeria, Mexico, Texas, Sweden, a couple of people from Canada. Again, welcome to today's webinar. If you're just joining, please drop the location you're tuning in from in the chat. There may be someone joining from the same location as you, so make sure you're responding to everyone. And we'll get started in just a minute. Hello from Japan and Brazil. We have a couple of people from California, but only one person from Florida. You may be the only person in the chat from Florida, unless there's someone else joining. Okay, it looks like we have a good amount of people, so I'm going to go ahead and get started. I'm happy to welcome you all to today's webinar, Intro to AI Agents and Agentic Systems. In today's webinar, we have Staff Developer Advocate, Richmond Alake, who will be taking you through today's presentation. But before we jump into that, we're going to go over a couple of quick housekeeping notes. This webinar will be recorded and shared via email early next week. So if you missed any part of this webinar, don't worry, the recording will be shared with you to watch at your convenience. All participants will be muted, so if you do have any questions, please use the Q&A box for that. The Q&A box is located at the bottom of your Zoom panel, and it shows a box with a question mark in it labeled Q&A. For live comments and general discussion, please use the webinar chat. There will also be a short survey shared at the end of this webinar, so we'd greatly appreciate your feedback if you fill that out for us. Now I'm going to hand it over to Richmond to begin today's presentation.
All right. Thanks a lot for that, Nia. Thanks for the intro. And thank you all for joining me today to talk about AI agents and agentic system, the one topic and the topic that everyone around the globe is talking about within tech. So today you guys are in for a treat, because when I was putting the web content for this webinar together, OpenAI decided to release their SDK, agent SDK, the OpenAI agent SDK. So today, that's what you're going to be getting from the code we're going to be presenting. I'm going to be showing you how you can use the OpenAI Agent SDK to build your AI agents, your agentic systems with MongoDB. So you're going to be learning how to build AI agents that have some memory connected to a database and can store the conversation history. So you guys are in for a treat. Let's make it official. So we're going to be covering overview of the AI stack. So I'm hearing the screen is at the bottom. Can you adjust it? Nia, is everything good with the screen from your side?
Yes, everything is good.
Yeah.
Uh,
Yeah, then I guess it's must be that individual screen. So we will get going. And anyone tuning in from the UK, I didn't see anyone from the UK. No, actually, I saw Manchester. If anyone's tuning in from London, put that on the chat. I'm only seeing the top of your head. Let's see. Okay. Is this a problem that everyone's having? Can everyone see? Give me a comment on the chat if you can see the slides that I'm showing very fine. Looks fine. Looks fine. Okay, that's it. Majority carries the vote. We're gonna carry on because we got a lot to cover. Thank you, chat. So we're gonna be looking at overview of retrieval mechanisms in AI agents, and because retrieval mechanism is the foundation of AI agents in general, then we're gonna be looking at agentic spectrum and what is agentic, what can be considered agentic. Then we're going to be looking at some definitions because we need to define stuff. But the exciting bit is we're going to be looking at some code, and I am going to be giving you some code during this webinar. So let's level set. LLM powered chatbots came into the scene. Things like ChatGPT came out maybe 2.5 years ago. We're able to ask some questions, and it gave us generic answers from its parametric knowledge. But then we connected these LLMs into knowledge sources to give us more relevant answers with questions that we gave them. We call this RAG or RAG-enabled chatbots. Now, the LLMs have emergent abilities such as reasoning as well, to use and function calling, and they're getting better. So what that has led is a new form factor or the form factor we're seeing today, which is AI agents and agentic systems. So today you're going to learn how to build AI agents and agentic systems using MongoDB and using the OpenAI SDK, Agent SDK. Whenever I give this webinar or just talk about AI applications, I need to define what the AI stack is because I will use it several times during this presentation. So the AI stack is just a set of tools and libraries and frameworks that come together to build AI applications with, in this case, generative AI functionalities. So you probably see a lot of C-suite folks or a lot of VPs talk about the AI stack at a high level. I like to double click and talk about the AI stack from a developer's point of view. So when you guys are building LLM application, what you care about are the programming languages, right? Are you building using Python or JavaScript? The model provider, open source, closed source, OpenAI, or are you using some open source model from Hugging Face? Also the LLM orchestrators and framework, LangGraph, LangChain, Llama Index, and whatnot. Also, the key part of where we stay, operational and vector databases, that's MongoDB. So you can use MongoDB as your single database solution for AI application. Then you have your monitoring and observability. We're going to be seeing a bit of that today because OpenAI also released an observability and monitoring platform, right? Where you can see the execution logs of the agent itself. So we're going to be seeing a bit of that today. Then deployment. So that is the AI stack. But before we get into the fun stuff, I want to talk about the foundation of most of the exciting things we talk about today. And everything is rooted in information retrieval mechanisms. We need to actually first, before we go into the space of agent, need to actually understand how we can give agents relevant data for it to give us relevant output, because that's what it's all about, right? Giving the agent the data they need to answer queries from your customers or from yourself if you're building local LLM applications. So information retrieval mechanisms are the systematic methods that we use to extract and process data. And you're going to be seeing three key ones today, and you guys have probably heard about it. We have database retrieval mechanism. You're going to be seeing full text search, how you can use MongoDB to implement search mechanism, text search mechanism. And this is just using keyword matching against the corpus of document. Then you're going to be seeing vector search. This is semantic search. You're searching by meaning. Then you're also going to see the combination of both of it in a unified search we refer to as hybrid search. Because with the MongoDB query language, you can actually construct pipelines of vector search and hybrid search and rank the results together. So we're going to be seeing all of that. You're going to be learning all of that. And then the other retrieval mechanisms, you can make REST API calls, do searches to the internet, or even do some form of geospatial search. And all of this ways of getting information form the backbones of some of the key tools you see in AI agents and agentic systems today. And we're going to be seeing a lot of that. So we're going to be using MongoDB Atlas Search, Atlas Vector Search, and the MongoDB query language to enable three key search mechanisms for our AI agents. And this is something that if you're used to MongoDB, you would have seen before. If you're used to coming to this webinar, you've seen before. MongoDB just doesn't have a database. MongoDB Atlas offers a bunch of features that allows you to build modern AI application, triggers, MongoDB charts, and stream processing. So all of this is within MongoDB Atlas that allows you to build applications for the future. And within MongoDB, you can use MongoDB as that operational and vector database for your AI application. We're going to be seeing a lot of that today. So if you have any questions, please use the Q&A. Use the Q&A box, and I will be looking at that during the webinar or when I take a break, and I'll be answering questions from there. So if you have any questions about what I'm talking about or what's happening in the space, you can just place in questions there. So let me just go over some background and details around how search works. So we have MongoDB Atlas Search, and really what we're seeing here is searching by keyword. So imagine you have a keyword artificial intelligence, you enter that through some input text in your application layer, you send the keyword to your data layer for it to search for relevant documents using keyword matching techniques, and then it gives you a bunch of results that have artificial intelligence within the specified path or attributes within a document. Then you can display the results. That's a text search, lexical search, however you want to call it. But now you have vector search, which is searching by meaning, which is we take a phrase or a keyword, we pass it into an embedding model, and then what you get is a numerical representation of your data object. And with MongoDB, you can actually start to do vector search against the query vector and the vectors you have within your collection. Then you get semantically similar documents from your collection, and you can then use this to power your RAG or recommendation system and your AI agent system we're going to be seeing today. I love the fact you guys are asking questions. We've got questions coming in. So when I take a break, I'll be going through the questions. Now we covered text search, vector search, but you can unify both of them to actually create hybrid search where you have the vector search and full text search. You get the results where you're retrieving by semantics, so you're retrieving by keywords, and then you rank the results to get this unified search. So this is hybrid search. And again, I think I said this loads of times, you're going to be seeing that today. Now we're into the fun bits, which is RAG. So I didn't want to just go straight into agents. I wanted to talk about the foundation. So we talk about the search mechanisms that we're using today. Now let's talk about the application, the applied part of it, which is RAG. What applications can we see today? So RAG is retrieval augmented generation. And what we're doing is we're augmenting the parametric knowledge of the LLM with some domain specific data or relevant data. And we're essentially concatenating some additional data with the prompt and pass it out to the LLM to get more relevant response. And that works really well. We're going to be seeing that today. And this is what a RAG pipeline looks like. You get the raw data, you prepare your data, chunk it, generate some embeddings. And one thing you can do with MongoDB is you have your metadata and you have your embedding data, and you can store it in one database. So you don't need to use 2 to 3 different databases for your AI application. You just need MongoDB, you just need one. So MongoDB actually touches a number of parts within your RAG pipeline. And some of you might have heard, and which is we brought in Voyage AI into the MongoDB team. And what we have now is the best embedding models and re-rankers within MongoDB ecosystem. So there'll be more on that coming out in future webinars. But today you get to see how powerful Voyage AI models are, because we're going to be using one of the latest Voyage AI models. So the fun part, the bit we've all been waiting for. What is an AI agent? Well, the term AI agent is really contested, right? So there is not one definition. So the definition I give might not be the same the definition that someone else might give. And to be honest, agent is a word that has existed for decades now. But within the context of AI or generative AI, an AI agent can be seen as a computational entity that has awareness of its environment and is able to act on his environment through tool use or take actions on it. But he's also able to perceive his environment. But also add a caveat that an agent should have some form of memory, short term or long term. This makes it really truly fulfill that promise of artificial intelligence, which is to mimic human intelligence. And humans, we have memory. So if there's going to be any computational entity that's going to try and mimic us, it at least needs to have memory. So in my opinion, agents should have memory. So what is an agentic system? Well, an agentic system is an architecture that actually contains one or more agents, where the agents can access the system components and utilize it for any objective that they are accomplishing at a certain period of time. So that is what we define as an agentic system. And again, you go to somewhere else, someone's going to have a different definition, but it's all converging, is all consolidating, and hopefully we have a unified definition soon. But until then, welcome to the agentic spectrum era, right? We have different definition, so you can see if something is agentic as sort of like a I don't want to use the word vibe, but if something is agentic as a spectrum. So when I was creating this the code section, I was trying to explain the different type of agents. Then the level one was a minimal agent. So I see a minimal agent as just an LLM that has an instruction and I can operate in a loop until it's achieved an outcome. So that is why I call a minimal agent. We're going to be seeing that. Then we have controlled flow agents, which is you're making the agent more deterministic. You're setting the sequence of execution and you're not allowing any decision making within the LLM itself. Then you have routing and specialized workflow agents. You're going to be seeing that today as well. You're going to be seeing level one. You're going to be seeing a bit of level two and level three. Then level four is the ideal state we want to get to, right? Autonomous agent. I just want to give the agent a bunch of tools and give it its mission, and I want it to achieve it. And I don't want to be involved in the process too much. So autonomous agent, we're not going to see level four, but level one, two, three, we're going to see bits of today. Yes, please ask questions in the Q&A. That is the one that I focus on to answer questions. So just to give some more background there. So we started with hey, we gave a prompt to an LLM, we got a generic output. I could have asked this prompt to an LLM and it could have told me the same output as if it would give you if you were to ask the LLM. So what we then did is we said, hey, let's get some relevant data, pass it to the augment, concatenate it to the prompt, and pass it into the LLM and get more personalized response. But now with AI agents, what you get is memory-backed AI agent, emergent abilities such as advanced reasoning and an ability to perceive its environment and a bunch of tools. You get more objective-driven system in which you can ask a prompt, give the agent a prompt, it can execute the prompt, and then ask if it should complete the next objective or just complete the next objective without asking. So this is more of an objective-driven interaction with computer systems. So an AI agent, memory, perception, tools, planning, and these are the characteristics of agents, right? They're reflective, they're interactive, they're autonomous. Sometimes, right, we saw the level, and they're reactive and proactive. So agents can react to certain things. Can you suggest any AI agents which can help me get a similar hairstyle to yours? Wow, interesting. That will be the next webinar. So let's go. So reactive and proactive agents. And one thing, I think there's a lot of people that have just joined us recently. So what we're covering today is AI agents, agentic system. But one thing that wasn't in the landing page of the webinar is I'm going to be showing you how to use the new OpenAI agent SDK. So if you attended this webinar, you're going to be getting the code for this in about 5 minutes. Okay, let's go. It looks like there's a lot of things happening on the screen, but I can explain it very simply, right? So we understood that agents need memory, perception, tools, and planning, but there are more aspects to it. And I'm only going to focus on that memory bit because that's where MongoDB resides. So if you think about a human, we have different forms of memory, and the most intelligent human I know is able to recall information impressive rates, and that really is what we determine, I guess, loosely IQ by. So we need our agents to have good, robust set of memory to be at least reliable, believable, and capable. So one thing I've noticed is people actually implement memories in different ways. You can have short term, long term, and you can have memories for your conversational store, episodic memory, your knowledge base. We're going to be seeing some of this today. Even the context window within an LLM is a form of memory. It's just a short term memory. So don't store your conversation history in the context window and expect to see it there in a new session. So the context window is a form of memory, but it connects all the way back to the LLM over here. So that's the key bit, memory. Now, just to bring everything together back to how it all fits within the pipelines you're used to, or within an agentic system. So you're familiar with this part where we're getting a data source, we're preparing our data, chunking, splitting, doing all the good data science stuff, and then we're generating our embedding. And now what we're actually doing is when we pass this data into the database, we give the ability to retrieve information from a database as a tool to the agent. Right now, you're getting into the realm of agentic RAG. So I think I've used all the buzzwords in the agent space today. So if I've not, tell me any buzzwords you know, and I'll try to use it in a sentence. And the best way I describe if you of how you can think about agents to people building it is to describe MongoDB as a memory provider for agents. And I see some people are having issues with my video. It's got to the bottom, but yeah, it's happened to me. So yeah, if you can reopen the Zoom app versus it being on Chrome, thanks a lot, Chichi, for that for that tip there. So I think you have to reopen it. So I'm just gonna keep going. So MongoDB is a memory provider for your agentic system. This is the best bit. This is a fun bit, the code and demo. So I'm gonna change my screen. And if you've been to my webinars before, you know I like to start at the end. By starting at the end, I mean I'm gonna show you what we're gonna work to. So let's go. One thing I'm doing within this code demo, I'm going to zoom in a little bit. Some of you are very observant. You're going to see a bunch of health information. So this is a virtual primary care assistant, right? This is the agent we built today. And this agent has a set of tools, and its job is to answer any medical queries. So I had a cough about a couple of weeks ago. So this is why most of the examples are around cough-related issues. So I asked the agent a couple questions around cough, and you can see the question right here. I said, give me some details related to cough in patients and medications as well. Now, this agent has a bunch of knowledge around previous medical interactions and also details of drugs and reviews on the drugs as well. So this agent was able to gather some information around some of the conversations around cough and also some of the medications as well. So this information is coming from two different data sets, and they've been retrieved in different ways, which I'm going to show you. So this type of system is what you would see in like in like your local, we call them GP over here in the UK, like in your hospital, in your clinic or clinical practice. Hopefully your doctor is not using ChatGPT to diagnose you, but this is something that would help a lot of medical assistants, right? You have a bunch of cases and you just want to quickly bring up relevant cases on the spot. And this is something that you can build for doctors. So you can see a bit of formatting here with the final response. And obviously the LLM is always telling us to consult with a healthcare professional because it's not. So we're building a virtual primary care assistant using the OpenAI Agent SDK And this assistant has different forms of memory, including the ability to store history. So I am going to let me actually run this because I think this is still, we're still able to run this. So let's start the chat session. Let's see what's gonna happen. MCP, that's a term I've not used yet. So I'm not gonna be using MCP today, but maybe in a future webinar, we might be using one. So let's go. So what health concern can I help you with? So can you give me cases about on cough? And so one thing you're seeing there is saying new conversation started and it's giving us a thread ID. So the code I'm going to give you later today shows you how you can use MongoDB to store your conversation history that is happening between your agent and your user. So this is important because you can, one, persist information, persist a conversation session, and you can then load maybe in a different session, start a new one. So the agent is giving us his answer. It's going to be similar to the last one, which is, let's go. So we have an orchestrator. So I have an orchestrator agent that can orchestrate two other agents. So you're going to be seeing a multi-agent system here today. Apologies. So I see people asking for the collab. So let me share it. I think we've hit peak threshold of attendees. So on the chat, I've just shared with you the GitHub, the collab link for this code. You can follow along. Oh, slight cough. You can follow along and look at the code and essentially learn as we're going along. So one thing I do ask is, I share this code, but I do want you guys, AI developers, to star the Gen AI showcase where this code resides in, right? Star and watch it. We're almost at 2,000 stars. So get us over the threshold. So if everyone here goes to the repo and star it, we are going to be golden. We're going to cross 2,000. Thank you, Perry, and everyone else that's going to do first one to start a repo. So let's go back to our agent. We can't ignore the agent for too long. So the agent has actually gone into its knowledge source and given us scenarios where there's been a doctor-patient conversations around cough. Now, we can see some issues, and a medical practitioner can look at this and say, okay, is there any similar scenarios I'm experiencing right now with the current patient? Then they also gave some medical information as well, some of the drugs that were used as well. And this, I'm not a medical expert, but this is useful for medical professionals because information, sourcing and surfacing up information and the right information at the right time is very useful. So here we can see the child had some breathing difficulty, and there's a bunch of formatting we do with this agent as well. Let's ask you another question. Just to prove it has some history stored, what was the first question? What was the initial question I asked? So now it should, because it has a reference of his memory. So let's see. Did that go through? Let's see. Let's try that again. What was the first question I asked? Pressed enter. Let's see. Okay, there we go. So your first initial question was about cases related to cough. There we go. It has some form of conversational history. So how did we build this? Well, we built it with MongoDB, we built it with Voyage AI, and we built it with OpenAI as the LLM and using the OpenAI SDK agent. That's what you get with this notebook. The notebook is long, and I call it From Zero to Hero, Mastering Generative AI with MongoDB. I am not that great with namings, but I do try. So let's talk about the key parts of this agentic chat system. And I've split it into parts, and I've kept some knowledge checkpoints for you guys to just get key information and understand what's going on. So we have the agentic chat system. That's what we just saw now. The agentic chat system can store history. It manages sessions. You can see it started a session beforehand when we started it, and it then is able to persist the session. And then we can actually order the chat history in a way that the agent is able to understand what was said first. So this part of this notebook shows you how we implemented the the chat history. So we created a collection in MongoDB called chat history, and then we're able to implement this function called a virtual primary care assistant and execute a bunch of the agent with storing the chat output into the chat history collection. I don't want to focus too much on this because this is going to get away from the key thing here, which is the agent. So let's go and start from some of the things we spoke about in the previous slides. What are the retrieval mechanisms are we using? Let me start with the data sets I'm using. So I'm using a data set called Chat Doctor. These two data sets are from Hugging Face. I've kept the link to them here. So we're actually just going to use about 1,000 data points from each of this data set. Each of this data set contains information. The Chat Doctor contains patient and doctor conversations. And that can help, that could be a sort of a knowledge repository or data repository of medical cases that we can use that is usually stored within a hospital database. And you can use this to give doctors real-time information or some knowledge of previous cases during a current patient interaction. And then we have another data set that has it's called a drug review data set. Now, this also contains some drugs patients have used and the reviews of the drugs and the effects and whatnot. There's also ratings on it as well. So the initial part of this notebooks goes through some data loading and a data preparation stage of this data set that we load from Hugging Face. But to focus on a key thing, we're using Voyage AI embedding model. Specifically, we're using the Voyage free large model. Now, this is a powerful model. This is a powerful model that allows you to turn any data object into numerical representation, and is one of the best models on the market today. So that's what we're using for this notebook. And the one thing is, with Voyage AI, once you have your API key, you actually get 200 million token free. So what does 200 million token mean? It means you can create your POC and probably handle a bit of production in production use of your application just by using Voyage AI for free. So 200 million token is, I don't know how many Harry Potter books that is. I'm using Harry Potter because I'm in the UK. Maybe 10 Harry Potter books, the massive chunk, big ones. I've never read them. But that's Voyage AI. In this function, we're going to be taking our numerical representation of data. We're taking our data object and converting it into a numerical representation. So that will look like this. So this is the input from the healthcare conversation. Hey, I woke up feeling something this morning. That was a patient. And then this will be the output from a medical professional. And then we've concatenated the input and the output and converted it into a vector embedding to enable semantic search. Now, I said text search, semantic search, hybrid search. Let's look at those foundations of retrieval mechanisms in AI agents. And after we do that, we're going to then be looking at how we built the agent using OpenAI Agent SDK. So I'm going to be talking about the OpenAI Agent SDK, and I'm also going to be talking about how I feel about it, because I've used the Pydantic AI framework. I've also used the LangGraph framework. So I think I'll give some opinions on things as well. Okay, back into the code. So we've generated the embedding using Voyage AI. So let's focus on creating the search mechanisms. So one thing you need to do is with your search mechanisms, you need to create two data structures. They're called two indexes. Your vector search and your search index, your actual search index. Your vector search, this takes you through the step of creating a vector search index, which just looks like this. You specify the type of the index, the path to where the embedding is, and the number of dimensions that you expect each embeddings to hold, and the similarity function you want to use to calculate the distance between two vectors. And that's how we calculate things. The closer two vector embeddings are, the more semantically similar that they are, the more relevant the query vector is to the other vectors within your collection. So this is a vector index. I've tried to put as much comments to explain what each attribute is. And I'm going to be updating this notebook with a lot of comments. So you basically get all the key information within this notebook. Okay, so we also create our search index as well. Over here, we set up the search index. We need the vector search index for vector search, and we need the search index for text search. And we also need both of them for hybrid search. So let's get into defining some of our functionalities. So the first one we're going to look at is text search. And it's very simple with MongoDB. We implement this function called text search, and we use a search operator, passing what index we're using, the one that we created earlier. We pass it in by name. And also we specify the path or the paths where we want to conduct the search for the keyword within. So the paths I'm actually using is from the data set. We're using the reviews path, and I can't remember. I only remember the reviews one, but it's in an array somewhere in this path array. We're probably going to see it later. Then what we have is the limit stage and the project stage. We project out the embedding, and we also project out the ID because the LLM doesn't need that to answer a query. So next, we test things out. So yes, the paths we're doing the search on is the review path, the drug name, and the condition. So we're going to look for anything that has cough within this attributes. And someone just asked, how do we rank in hybrid search? That question is going to be answered in about 10 minutes or less, because it's in there in the code. So this is text search, and this is how it works. And we can see it working right here. We ran the search, and we're able to get the drugs related to the cough condition, and these also have cough in them. Great. That's text search. Now let's search by meaning, search by vector. Here we have semantic search with MongoDB, and very quickly we have stages, just like we have in the search operation. We have a vector search operator, and this takes in your index name, the path you want to search against, the query vector, the path you want to search against, the number of candidates, and the limits of the search itself. So very simple, straightforward. You create a vector search stage, a project stage, and then you just place it in a pipeline and execute a pipeline using the MongoDB aggregate framework. And this would give you a list of documents. And we do the same thing. I have a cough. What drug can I use? And it gives us some drugs that are related to, that are semantically similar to the query that was asked. Some documents are semantically similar to the queries that was asked over in the previous cell. And you can see the semantic similarity over here, 87, 87. They're pretty high similarity or relevance to the actual query itself. So we've seen text search, we've seen vector search. Let's combine it and move on to step 10, where we see hybrid search. Why am I showing you all of this? It's because the foundation of AI agents and agentic system lies in information retrieval. And this is as basic as you can get, right? Doing text search, doing vector search, which everyone is very excited about now, and combining them together to do hybrid search. So here we go, hybrid search. Someone asked, how do you implement hybrid search? MongoDB query language is very robust and is very intuitive. It gives you the ability to implement hybrid search in the way that you want or the way that is more suited for your use case. So with the MongoDB query language, you can actually construct a pipeline. So I've broken down the pipeline in parts. So the first part of the pipeline is going to be, we conduct our vector search. Then we get our results and we store the vector score of the result. And then we also have this key part, which is how we rank someone asked a question, how do we rank the results in hybrid search? This is how we're ranking the results. This is a reciprocal rank fusion algorithm. And then we're able to project the score. Now we have the text search aspect as well. And we do the same thing as well. Then we're able to combine the results. And then we have this hybrid search, and we limit the result to give us only maybe the top K that we've specified. So that's how we do hybrid search. It's commented in the code, and it's easy to follow along. And hybrid search, we run the same query. I have a cough. What drug do I use? Here we go. We get a bunch of unified search results. Excellent. So that you see a knowledge checkpoint here just to say, hey, you now understand hybrid search, you understand text search, and you understand lexical search. So one thing also included in this code is how you can just build a very simple RAG pipeline. So we're using the chat completion API from OpenAI, and we're just going to build a very simple RAG pipeline. And that's what we're doing in this part of the code. So apologies for the scrolling. We're creating a custom RAG pipeline. Of course, you can use framework like LangChain and Llama Index and Haystack to simplify all of this process. And you should, because MongoDB has integration with all of this, frameworks and tools as well. But I'm giving you the raw information, and it's very simple to create a very simple RAG pipeline that can take in a query and a collection, and then you can use the user query against the collection. And we're going to be using hybrid search for this RAG pipeline. But for those of you going through this, you can change out this hybrid search for just pure vector search. So in the first step of this RAG pipeline, we get our search. We're going to format the retrieved. We're actually going to format the document so we can the LLM can make better sense of it. So there's some context that formatting that I've added, which is just telling it what it's expecting, and I've concatenated each document with the right information as well. So we do the formatting. Step 3, we craft the entire prompt. So we tell the LLM based on the questions, based on the question and the information provided, answer the query. Based on the query and the information provided, provide an output to the user. So we then pass all of this. We pass the context and the prompt to the LLM, and then we're able to get a response. So I can ask it, I have a cough, can you help me with some medication? And it can give me some of this. It can give me like a more human answer as opposed to a bunch of documents. There you go, RAG using hybrid search. And there you go, that's another knowledge checkpoint just to tell you what you've just learned, what you've seen. And now we can go into the cool part, which is the AI agents aspect. And OpenAI released their OpenAI Agent SDK a few days ago. Has it been a week yet? Don't know. The AI space moves way too quickly, but they released it some time ago, and it's called the OpenAI Agent library. So you can install it using pip, and that's what we're doing over here. And if those of you that just joined, or those of you that joined earlier, you can see that we're going to be creating a minimal agent. And I define a minimal agent as an LLM that has an instruction and operates within a loop. So here we go. We create this minimal agent. I keep some explanation as to the different ways you can execute an agent. So you can use run, which runs things asynchronously. You can run sync, and you can also run streamed. I think run streamed is the best method for your AI application. I use run because I'm just demoing things over here. So run stream means that you're going to be streamed. The token are being streamed as they've been streamed, but as they've been received from the LLM or from the inference endpoint. So you'd have to wait for the full response before you show it, before you get your results from the inference endpoint. You get it token by token. Okay, so, and also you can't run sync in a Jupyter environment because it won't work, because there's already it won't work because there's already an event loop within the Google Colab environment already. So you get an error if you try this anyway. We're going to be using GPT-4o, and it's very simple to create an agent with the OpenAI Agent SDK. All you have to do is just import the agent module and the runner module. The agent module is going to give you the ability to create an instance of an agent. And here we can see we're creating our virtual primary care assistant, and we're making it use the GPT-4o model, and we're going to give it a set of instruction. And that's it. You have an agent. Now that you have an agent, how do you execute it? This is where the runner module comes in. And that creates an environment, which essentially is it's a loop that the LLM can run within and look at the outputs that has been generated until an exit condition is met. So we run the agent within this loop, until the exit condition is met, and we're passing the input over here. And there is a starting agent. There's a starting agent context within the runner class, and this, I guess, I don't know why you have to define a starting agent, but we'll see. I'm still exploring the library a bit more. So, but they have the starting agent. This is the first agent that has been executed, the entry point essentially. I think in LangGraph, and I do, because I have to play with a lot of agentic frameworks, I have a LangGraph notebook opened, and you can see LangGraph actually have this set entry point. So that's kind of similar to OpenAI's starting agent, right? LangGraph has a entry point for the nodes you create, and we have loads of webinars and content on LangGraph as well. And someone's asking, what's the exit condition? In LangGraph, the exit condition is explicitly stated, but also in OpenAI SDK agent, you can actually force an exit, and I think the exit condition is within the raw output as well. But again, still exploring this library, relatively new. I'll have more information as I dive deeper. But you can see that there's just a similar concept of start an agent or start entry point. And so that's what I'm trying to show you. Most of the frameworks are kind of similar in a sense, in terms of the concept that they bring. So there is a poll question that has been shown to you guys. So just to rate the webinar session, and also to tell, so if you could answer the poll questions that's been shown to you on the screen, this allows us to come back better, allows me to deliver more better webinars to you guys, and give you top information. So fill that out, and I'm gonna go ahead with this webinar. So that's OpenAI SDK, agent SDK. Very easy to, just a few lines of code. We created our agent, then we executed our agent, and now we can see the output of the agent over here. Now, the question is very generic, so he's using his parametric knowledge to answer this question. So there is no MongoDB memory concept over here backed within it. Now, let's go into agentic RAG, another key term people use. So the way you can define tools for your AI agents or for your agentic system is by using the function tool decorator. Very confusing, but it's the function tool decorator, meaning that you have functions that can be used as tools for the LLMs. And you just have a Python function that has a Google Docs string. And right here, you can see that we're going to be using that hybrid search function we created, earlier on within this notebook. So this is it right here. You have to make this very descriptive to let the agent know when to use the tool itself, and also name your functions properly as well. Make them as descriptive as possible. So this is a tool. We create a very simple tool called Get Medication Review that can go into the collection we created with all of the data around the drugs and their reviews on their performance and their effect. So we take the same user, we take a user query, and we get the relevant document. And that's what this tool is going to output, a bunch of documents that match the user query using hybrid search. Now, how do we get the agent to be aware of the tool? It's very simple. We just call the tools object and append to the list the get medication reviews. And that's it. We've added the tool to the agent. Now the agent can use the tool when it's called upon. And that's what it does here. I asked it to get me information on cough medication and the reviews. And it now uses, it gives us more direct answers. It's no longer generic. And I can tell it's using some form of search, because it's giving me the score. It's also giving me the reviews as well. But with the OpenAI SDK, the agent SDK, you can actually look at the raw responses and see each of the execution steps. So you can see that it's gone in here and zoomed in too much there. It's used the response function tool call, and it's actually called, he's passed in the cough medication into the get medication review tool. So you can see that this is a function call. Then he's used the information to generate an answer for us. Next step I show you in a notebook is how you generate is using multiple tools, right? You don't just want one tool. You want to give your agents as many tools as possible. So this is the next tool we're going to create, the Get Past Medical Conversation tool. Remember, we have a data set, another knowledge source with conversations between a medical practitioner and a patient. And now with that tool, I don't want to use hybrid search. I want to use semantic search. So we have an agent that has two sets of tools and is using different retrieval mechanisms. So here we're just going to search just by meaning. So again, we get the same. We actually get the return documents. And now I've made the prompt a bit more more directional. The instructions more directional, making it aware of some tools it has. You might not need to do this sometimes. I just do this from practice to make sure the agent is aware of the tools that it has, but you don't really need to do this. This is overkill. So again, we create a new agent. We've upgraded our agent with two tools. It still has the same name, same model, more beefed up instructions, and we can add all the tools that we have to it. So we're going to add to the new agent the Get Past Medical Conversation and Get Medical Reviews. And you can actually see what tools the agent has by calling that tools object. And you can see it has the function tool over here, which is a Get Past Medical Conversation, and another one, which is a Get Medication Reviews. This is just to make sure. And now we can run the agent in the runner to actually give some outputs to the query, which is the same query, right? I have a cough, give me some medication, and give me some relevant past scenarios. And here we can see the output, right? It said it's giving us the output of the medication and some of the past medical conversation. So it's used two tools. And I told you OpenAI, they've gone into the space of observability, and I'm showing here that the tools are being used right over here. So I have the traces of the execution. It used the first tool, and then it used the second tool, then it then generates us the output. So you can use the whole ecosystem of OpenAI for the observability and monitoring side of things as well. So for the sake of time, this is the last pattern that I show, right? Which is using agent as tool. So we saw the minimal agent, right? Which is fine. We saw a single agent with multiple tools. Now you can actually use the agent themselves as tools with the OpenAI SDK agent. And that's what this section shows with a bit of orchestration as well. So if you follow the code, there's a bit of comment to tell you what's going on. But we have two agents. We have the medication agent and we have the conversation agent. So here we have a multi-agent system. But what I actually do is I create another agent called an orchestrator agent. And this then uses the other agent as tools. So rather than you having a single agent with multiple tools, you can have multiple agents that have access to their own tools or a set of tools, then use those agents as tools. So, which is pretty cool, essentially. Now, so you have an agent acting as a tool that is a tool for another agent. It's confusing. We need a visualization of this. But I've shown you what this resulted in at the beginning. And just to end on the output of this, when you run this, you actually get this output where the agent is able to orchestrate one tool after the other and get the output. And if you go to the next part of this notebook, which is the agentic chat system, I show how you take the orchestration agent as a tool design pattern and place it within a system that can store the conversation history within MongoDB. So that way you have an agent that actually is stateful, can remember information from previous encounters. And that is an introduction to AI agents and agentic system using OpenAI SDK agent. We've got a bit of time, so I'm going to be going through some questions, and I want you guys to place questions, to place any information you have, any questions you have on the Q&A. But also, I'm going to share the code again in the chat. I know it's been shared a lot of time. Go to the Gen AI showcase right over here and showing it on the screen and start the repository so close to 2000. Start the repository, fork the repository as well. And you can also watch the repository because this is going to be getting updated regular. Oh, look, it just got updated now. So we've got some new structure, and this notebook resides within here as well. So start the repository. We're going to be giving you more good content. And I'm going to go through some of these questions as well. Share my slide. Not share my slides. Slideshow. There we go. So I'm just going to pick up questions. I can't get through all of them, but I'll try to answer them as much as possible. Is it possible to use a different LLM API other than OpenAI? They say that the framework is going to be LLM agnostic. So we will see if they allow other folks, or they have integrations to other APIs, or maybe they even have integrations for other databases as well. Again, please describe what will. So there's a question asking to describe what will require Atlas versus what can be done with on-prem deployments that don't use Atlas. Well, vector search capabilities within MongoDB Atlas, and will be coming out to on-prem deployment very soon. That's within the roadmap. Okay, I'm going to be reading. Some of these questions are very long, which are good. They're very good. How do you enforce data access control? Specifically, I'm looking for a solution that can generate NoSQL queries from text while ensuring. Yes, so role-based access control is a very important topic, and I'm going to place that. Quick answer, MongoDB has role-based access control within MongoDB Atlas, and I'm going to be showing in some notebooks in future webinars how you can bring that to restrict some of the agent access to a few collection. So look out for a webinar or a tutorial coming soon on that particular topic. Yes, there's a lot of questions around data confidentiality around RAG application. How can we ensure confidential data is not leaked to external LLM models other than hosted them locally? Well, if you don't want to send your data to a third party, then you should obviously be hosting it locally, hosting your LLM application locally. You can also use some open source module as well, which again, you would host the model in some cloud provider, or you can host it on your local machine as well. But data confidentiality is a big topic. But MongoDB Atlas has a bunch of security features that ensures that your data is secure within MongoDB. But obviously, there needs to be some good data practice around role-based access control and security within agentic systems as well. How do we handle large document results sets considering the token limits in LLM provider? Are we still having token limits issues? There's like 1 million context window, but yeah, I understand what you're saying. How do you handle large document results? The way I advise folks is, firstly, you have to look at a RAG pipeline. One of the first things you do is you chunk and you actually generate your embedding. The embedding model you use really affects the retrieval accuracy of your system. So choosing the best embedding model can help your AI retrieval or AI search accuracy improve, which then limits the amount of documents you actually require to get to the right information for the agent. So if you're using the right embedding models that chunks the data appropriate, and you use the right chunking strategy, where you're converting the data object into numerical representation, you can limit the amount of information you need to get relevant output to your users by using the right embedding model. And in this case, Voyage AI provides state-of-the-art embedding models. So how do we handle large document results considering the token limits in LLM providers? Use state-of-the-art embedding models from Voyage AI and try to limit the amount of documents you're passing into your LLM. And you can also use a technique called prompt compression. We did a course on that. Let me see if I can get that very quickly. We did a course on deep learning AI that showed the prompt compression technique. I'm going to put that on the chat over here. So we did this course that shows how to reduce the documents and context you're sending to your LLM. but still retain some of the information quality. So check out the course we did over with deep learning AI. Okay, given a long context in a single string, what will be the best? Oh, okay, yeah, that question is answered with the course I sent. So next, let's go. How does MongoDB handle performance issues with relevant searches, both in runtime performance and relevancy performance? Well, MongoDB gives you different search retrieval mechanisms that we just saw. So you can start to play around and experiment with what gives you the best result for your data set, whether lexical, hybrid, or vector. But also, we are bringing in Voyage AI. We brought in Voyage AI, and they give you the best embedded model, state-of-the-art embedded model for multimodal use cases or for just text for different type of data set. They even have domain-specific embedded models. So this is how we're trying to improve the performance of AI search or AI retrieval in general. Okay, so we have this for requirements: geo search, semantic search, keyword search, LangGraph. Well, excellent. You saw 3 out of 4. So I showed you semantic search, I showed you keyword search, and I showed you LangGraph in a notebook. And if you go into the Gen AI showcase, we have loads of notebooks on LangGraph. So geo search with coordinates, and yeah, MongoDB does that. Check out the MongoDB documentation for geospatial search. I did cover geo search being one of the key retrieval mechanisms. So we have you covered, all 4 covered. Look at this webinar, look at the MongoDB Gen AI showcase, and look at the and you can also look at the documentation, the MongoDB documentation. Okay, so I'm going to go on.
Richmond, one thing really quick. If you can't
Yeah.
find the Q&A, please look at the bottom of your Zoom panel or click on more and select that, and you'll be able to drop your questions in there. Richmond, just click answer live for the questions, and also go to the slide. We do only have about maybe 2 more minutes as we're over, so we can only go over maybe 2 more questions. Thank you all again for
I'm having too much fun with you guys, but let's go. Does Nia's given us 1 more minute, so let's take one good question. Just looking. So let's go. There's some good questions here, but I'm looking for one that is very generic and we apply to everyone. So what do you think about automation platforms that allow to build AI agents like Agentic Hub, Relevance AI, Comparison? What do I think about them? Well, I think they're doing a very good job in helping people develop AI applications very quickly. And even I think the most popular one I've seen out here is NA10. They give you like you can put in the chat if you heard of NA10. And we actually just released one of our integration, MongoDB vector search integration with NA10. And what do I think about them? I think they're great. We're going to eventually work with most of them to make it easy to build these LLM applications with MongoDB. That is our mission, accelerating your adoption with MongoDB to build the future. So on that note, I'm going to end the webinar here. Thanks a lot, guys, for attending this webinar. We're here every Thursday. So, or you can reach out to me on LinkedIn if you have any specific questions, and we can carry on the conversation.
Thank you so much, everyone, for joining today's webinar. Richmond, if you could go to the last slide. If you haven't, please make sure to fill out the poll. If you'd like to speak to an expert, make sure you click yes in the poll questions if you haven't. Again, thank you so much for joining today's webinar. Please keep a lookout for the recording early next week in your email, along with some additional resources. The slide won't be shared, but the recording will, so you'll be able to watch this at your convenience. And make sure you register for more of our webinars, where Richmond will be presenting a lot more topics like he just discussed. Thank you all again, and I hope you enjoy the rest of your days.